Okay, let's rock and roll. We have video 3.6 here today on immune privileged organs. Another really excellent cross linkage of immunology and anatomy. So, very exciting stuff. What is an immune privileged organ? Well, we have certain anatomical locations where immune responses are limited or modified to prevent tissue damage. Okay, sometimes we don't want to release the hounds. We've talked about this whole semester just how powerful this response can be. And we have some organs that are very, very delicate, and we don't want to send such high levels of inflammation signals to something that, we need to maintain its delicate, normal physiology. So let's talk about that. So some tissues are delicate and non-regenerative too. Some of them can't heal. Some of them are heavily post the mitotic stage. So if we sick a bunch of these damaging chemicals that the immune system is secreting, albeit to try and help, but the fact is that these compounds, they damage intruders, but they also damage our tissue. So if we can't regenerate in that area, we need to pump the brakes. Sometimes even small amount of inflammation can be horrible, catastrophic even. So we need a balanced defense with preservation of immune function. All right, so what are some examples of where this phenomenon is taking place? First up is the eye. This is one of the best examples, I'd say. So why is the eye privileged? Well, the retina and the cornea must remain clear and undisturbed, unobstructed. This is my sensory organ, my visual receiver. If that is clouded with, a bunch of neutrophils, B cells and T cells and antibodies, well, then I can't see. And if we think back to the evolutionary aspect of things, if I need to run from a lion, well, if I am hearing a lion roar, that's probably too late. I would like to be able to see in advance. So we want that to remain open, that field of view to not be, inculcated with a bunch of the immune cells that we've discussed this far. So slight immune recruiting could really damage vision, and sometimes even permanently, right? The retina is neural tissue. Neurons don't regenerate, unfortunately. So that can be dangerous. So the blood-retina barrier and ocular fluids are rich in suppressive properties. I don't want to get into too much of the magic, but the signals, kind of like the gut microbiome, are telling the immune system to calm down. So we have a selection to more regulatory tone. So I'm going to be selecting more so for Tregs in this area, okay? And the humors, the fluids within the eye itself just have antimicrobial properties to them. Also, we really do rely on our physical defenses, right? We blink. We blink all the dang time. We have our eyelashes hopefully catch things before they get into the eye. And not to mention our whole lacrimal system, our tear ducts. Our tears themselves have antimicrobial properties to them. They have lysozymes within them to hopefully stop any type of bacterial colonization well before they invade the eye. So we really rely on our physical innate barriers at the eye, as well as ensuring we take that suppressive route as well. But this privilege can be a curse, okay? Clinically, this is a really cool example. I hope I never get it, and I hope you never get it, but the science behind it I find fascinating. Something called sympathetic ophthalmia. So let's say we get a blowout fracture in the orbit for however it's caused. Let's say Mike Tyson just clocks you right on your zygomatic arch, and the infraorbital, the floor of your orbit is just blown out. Well, now, my immune system didn't have any idea that there was a retina or parts of my cornea. It was ignoring that. The blood-retina barrier was putting a fugazi up that says, no, there's nothing to see here. We don't need to react to eye antigens because I want to make sure that this place is sacred, that I don't have a bunch of immune cells clouding my vision. But now the floor of my orbit is blown out, and now I have retinal antigens floating around in my blood. And my T cells and B cells have never seen that. They've never seen my retinal cells that are doing photoreception for me. So because they've never seen it, that's foreign. That is going to generate an immune response. So retinal antigens trigger my immune system. So what happens is, as that immune response develops, just like it takes a little time for that adaptive to kick up, in a week or two, that patient will come back and their non-Mike Tyson eye will be inflamed because the immune system has now realized, oh, there's a retina here, and I don't know what that is, so it needs to get the heck out. So a really crazy condition where, yeah, we want this to be privileged. We want the eye to be sacrosanct. I don't want a bunch of stuff clouding my vision. But if my immune system becomes wise to it, that's very scary. A cool fact here, though, corneal transplants, my immune system's none the wiser. No HLA matching needed. So that's a cool a sidestep for a treatment. We don't need to worry about that because the immune system, in all likelihood, should not be targeting any cornea areas. All right, so that's the eye. Great example. Then we have the brain. I would say it's getting less and less of a good example, but let's go here. So why privilege? Well, the neurons are post-mitotic, thus unable to tolerate inflammation. Again, inflammation is an inherently damaging process. Just think about when you have a fever. Yes, the whole point of the fever is to raise your body temperature to make the virus or bacteria or whatever uncomfortable. But guess what? If you've had a fever, you're also uncomfortable too. These processes they're meant to smoke out these diseases, but they do cause damage to yourself as well. And if that's happening to neurons that you can't regenerate, well, that's bad news bears. All right. A different BBB, the blood-brain barrier keeps out most immune cells and most antibodies. So we have that separation to hopefully mitigate any inflammation that could damage my neurons. You have microglia in place. That is kind of like the janitors, the supportive cells of your central nervous system that act as restrained immune sentinels, keeping the peace while hopefully not upstarting any inflammation. Okay. If privilege is lost here, that's neuroinflammation, so we can have really horrible effects. I mean, if you could just think of everything that your central nervous system is responsible for, it's a long, long list. Seizures could follow. Paralysis could follow. With paralysis, you could get muscle impairment. And if the things forming my thoughts are getting attacked, cognitive decline is highly possible as well. So a litany of issues could come from a full immune response on brain tissue. Very scary stuff. Now, I hinted that it's not the best example because, honestly, our understanding of the blood-brain barrier is not that great, at least from my perspective and what I've read. There's some really cool stuff on the, it's called the G lymphatic system, or the glymph. And this refers to the immune presence in your central nervous system. Yes, it has to be blunted because we need to tolerate inflammation, but there is evidence that there might still be some immune profile here. And I'm nowhere near an expert on this, and this is some cutting edge stuff, so if you get into some neuroimmuno, this is definitely a cool place to look into. But the only thing that I know for sure that I'm comfortable stating is that this is greatly improved with sleep. With sleep, so make sure we're getting our good sleep to allow whatever immune arm I have in my central nervous system. Good sleep flushes it out very consistently. That's all the paper. That's all. That's all from the paper that I could understand at my level of understanding. So that's what I'm going to convey to you folks. So yeah, glymphatics. I almost did a whole lecture on it, but I lack the expertise. So there is some immune presence in the brain to regulate things, but nowhere near to the level that we've talked about, where in tissue space we, ring the fire alarm and all the soldiers come marching in. That would certainly be horrible for neuronal tissue that's incapable of regeneration. So that's our brain, a cool concept there. Another crazy concept, the testes, so the sperm factory. Why would this be privileged? Well, think about it. Sperm antigens appear after central tolerance is set. Okay? Men aren't, or the early boys aren't making, that just sounds so weird. Sperm has not been generated at early stages of life. So this is something that happens after all of these immune cells have developed and figured out what to do. They have determined self, and sperm antigens have not been in that profile whatsoever. So sperm is viewed as foreign. There we go. So because they arise at puberty way later in life, the T cells, right? The thymus is involuting at puberty, so it's been working this whole time, creating T cells that have no idea what a sperm is. All right, so this is a foreign entity. Not to mention, it's only half of your genome. It's haploid, so there might be some triggers there that would freak out some immune cells. Regardless, the testes have something called Sertoli cells, and they form the blood-testes barrier. They have really strong junctions between them, and they allow for a walling off of the sperm from any immune cells that might be floating around in the blood. So thanks to the Sertoli cells and those tight junctions, we have a good blood-testes barrier that maintains the sperm population. All right, that was a struggle without saying something stupid. All right, what happens if we lose the privilege there? A couple things, right? Trauma. Torsion is a crazy thing. That's more mechanical, so that's kind of a stretch, no pun intended, that loss in privilege could cause this. But, or I'd say more so, if torsion occurs, maybe the mechanical stress messes with the Sertoli cell barrier. I think that's more so what I'm after. Same with vasectomy. You're going in there and clipping the vas deferens. Maybe that messed with some barrier some way, somehow. Maybe some iatrogenic hospital-generated issue occurs. Who knows? And then infection of the area. God forbid we get infection down at the testicular level. Well, that's going to recruit cells, and potentially, a very active immune cell might jump the blood-testes barrier, and we get a response. So any of these can release a sperm antigen, and then we get a response, and that's not good because ideally we would like to keep our meiotic cells. So anti-sperm antibodies would then be created. That would cause autoimmune orchitis, which is testicular inflammation caused by your own immune system. And if you have that full throttle immune system wiping out your spermatogonia, then that's going to cause infertility. Okay? So again, we see this double-edged nature of immune privilege. Really great to have this capability to hide, but if for whatever reason something, horrible or painful or unfortunate happens here, then that is going to run the risk of, making your immune system wise to the fact that you have cells that it hasn't really been exposed to. Okay, so double-edged sword here. All right, and last example I'm going to nail home is the placenta. So why is this privileged? Well, remember, the fetus is genetically half paternal. Fetus is grown in the ma, so we don't have, and she's not paternal. She doesn't have that genome. So it's essentially half foreign to the mom's immune system. All right, if maternal immune system recognized it fully, that would cause that would be a failed pregnancy. All right, so the trophoblasts are the fetal cells at the maternal interface. Okay, so they are going to lack MHC. So technically, they're invisible to T cells. All right, so the maternal interface here, right? That's the placenta. They are going to lack MHC. So yes, they're invisible to T cells, and now the placenta is also producing some suppressive molecules, telling the immune system, hey, please relax. But if we're being astute, remember, goodness, that's, all right, we're okay. We have cells that are capable of detecting if MHC is not present. Yes, our MHC is great at determining self versus non-self, at presenting antigens for me as well. But if it's gone, that doesn't necessarily mean everything's okay. Like, sure, my T cells might miss things and not react to it then, but we do have a response if MHC is gone because, well, some viruses downregulate MHC, and we need to recognize that as a problem. My NK cells are typically the ones that do this. But what's remarkable in the developing fetus, in the maternal, in the uterus, that environment, one of the most predominant immune cells is a variant of the NK cell called a decidual NK cell. And this cell's main game is maternal immunomaintenance, keeping everything in check, keeping the tone down, the immune tone that is down, ensuring that there's no hyperreactivity here in terms of viewing this fetus as fully foreign. These decidual cells are one of the major populations in the area to ensure that we don't have a total immune response in the area. So there's a real maternal nature to these, which I think is really cool. I had no idea these existed before I started researching for this course. So a really cool concept. That's the main player at ensuring that this is not deemed as a problem. Now, unfortunately, this still can be bypassed. This still can happen. What if the privilege is lost? Well, obviously, we would have a miscarriage follow there. If we have a full throttle immune response to something that has no defenses, that is still in the early forming stages, there's not much we can do there. That would cause a failure of the pregnancy. We can also potentially have some preeclampsia that can so hypertension caused by poor my gosh, I'm having terrible time speaking today. Poor placentation. So preeclampsia, just we didn't get a good lock in here with the placenta, and that causes extreme hypertension and poor nutrient delivery, and can also lead to miscarriage, and also cause just a lot of stress and inflammation in the area, which might drop the invisible act here. If I have more inflammation in the area, well, I'm more likely to cause an immune response to the stressed out tissue. So hopefully this is bypassed with these awesome decidual NK cells, but it is not always the case. All right, and then just to end things here, less concerned with these, but your hair follicles have local immune dampening as well, which is pretty cool to protect those stem cells and melanocytes. Sometimes that breaks down, though. Sometimes those that immune suppressive environment is not as strong as it needs to be, and then we recognize those follicular stem cells as foreign, and we can get alopecia. Or sometimes we can break down the barrier, and it deems the melanocytes as foreign. All right, we can get a condition called vitiligo. So that's the autoimmune condition that wipes out the pigment in your skin. So that's something that that's the disease that Michael Jackson had, and it's a yeah. So that's a cool concept as well, but harkens back to privilege. If we maintain that suppressive environment, then nothing goes wrong. So there's, again, double-edged sword. I already mentioned the corneal transplant. The cartilage is also very avascular, so there's limited immune access at certain joint sites. So there's some, rheumatoid arthritis implications there. And then anterior pituitary is also privileged due to that vascular isolation. So there's a pituitary portal system that filters things out, so it's not necessarily as exposed to the immune system as other organs are. But those are more secondary. I'm not as concerned with those. So just to 30,000 foot everything, so from a zoomed out perspective, right, our physical barriers are really important here. Blood-brain barrier, blood-retina barrier, Sertoli junctions, the trophoblast, that's the placental wall interfacing with maternal tissue. Those physical barriers are really important in maintaining this front. Also, a suppressive local environment. We already saw hints of this with the gut, with the GI tract, telling the microbiome, telling the immune system to not react to the microbiome. If I could get my thoughts together, yes. All right. Tolerant antigen-presenting cells, again, recognizing that we don't need to cause a reaction to things that are just regular stimuli, again, hearkening back to the microbiome. And systemic tolerance induction, just not selecting for that T regulatory pathway and in favor instead of generating an entire immune response to something that is delicate, like the testicular environment, like the ocular environment. So we don't want to cause a whole stink there because that would damage really delicate tissue. And again, the double-edged sword. So yes, this protects the delicacies from stress, but because they are protected, because they have not gotten to see the outside world, if that does occur through infection, through physical damage, through a mutation that causes those antigens to be exposed and relevant to your immune system, well, then we can turn that privilege into autoimmunity. All right, so another sprinkle of that autoimmunity. We're going to have a great time with it in Unit 5, but all of these powerful mechanisms we discussed really have a backhand to them, and that is absolutely present in the concept of immune privilege. Okay, I apologize I did a lot of flubbing there, but yes, so the main things I'm worried about here are the eye, the brain, the testes, and the placenta. Those are all really, really good examples, and I think they train us on understanding how responses happen and why we want to regulate that and why our T regulatory cells are so, so important. Pregnancies would be so difficult, also with the decidual NK cells. Those guys are cool too. Vision would be corrupted. Men could not produce sex cells. There's a litany of problems that would happen without good regulatory tone. So that's just something I wanted to hit because I think those cells are super cool and super important, and they provide such fundamental physiological buffs to us. So that's it for today. I hope you guys have a wonderful, wonderful weekend, and thank you for your continued attention.